In this presentation we're looking at mechanics. The first thing we're starting off with is the difference between scalar and vector quantities. They both have magnitude, but the difference is that the vector quantity has a direction. So if the spaceship's going to invade Earth, it needs to know not just what distance it needs to travel in, but also the direction of its travel. We can find the resultant vector by adding vectors together, and we do this in the following way. If I start off and walk 3 miles north and then turn and walk 4 miles west, I can draw a little triangle, and I can use Pythagoras' theorem to work out the total distance travelled in a straight line from my starting point, which is a squared plus b squared is c squared, and that in this example would give me 5 miles distance. And then I can use trigonometry to find out what direction I've travelled in. So the tan of that angle shown is 4 divided by 3, and when I work that out on a calculator, that comes out at an angle of 53.1 degrees. Similarly, we can split vectors into their horizontal and vertical components. So if we have an example of a jet taking off at an angle of 60 degrees from the horizontal runway, and it has a speed of 5 meters per second, what I'm actually saying is that its speed in the direction of A is 5 meters per second. Sometimes it's quite useful to divide that, or to break that down into its horizontal and vertical components. So if I want the horizontal component of that speed, I need to use the following equation, which gives us that 5 cos 60 gives us the horizontal speed, and that's 2.5 meters per second. And the vertical component of the speed will be 5 times the sine of 60 degrees, which is 4.33 meters per second. And if you couldn't use vectors, you probably wouldn't end up where you wanted to. We're now looking at motion with constant acceleration. Acceleration is a change in velocity divided by time. So if we start off with an initial velocity of u and end up with a final velocity of v, and subtract one from the other and divide it by the time, we get the acceleration, and we can rearrange that formula in the white box to give us the formula shown in black. The distance travelled is sometimes referred to as the displacement, and the displacement will be the average velocity multiplied by the time. If your acceleration is constant, the average velocity will be easy to find. We just add the final velocity to the initial velocity and divide it by 2. So just to recap, those are your equations. And then you can do lots more of rearranging and end up with a few more formulae. If we look now at displacement time graphs, we've got a graph of distance against time. We can see that in the initial part of the graph we are accelerating. Then when the gradient remains constant, that's when we're travelling with constant speed. And then the gradient is getting ever smaller, so we're decelerating or slowing down. And finally we're going no further distance, which means that we are stationary. And if we look at a velocity time graph, we've got that we start off from 0 meters per second and increase steadily to 20 meters per second. We've got steady acceleration. And then we maintain it at 20 meters per second for a little while, which means we've got steady speed. And then we decelerate. And in the final portion of the curve, we've got increasing acceleration because the gradient of the line isn't straight, it's getting increasingly steeper. And that's the end of part 1.
Created using Powtoon.